Welcome back, everybody. Good evening. So we're going to start here today with the second lecture, where we will be discussing a simpler version of the PageRank algorithm. Because the PageRank algorithm is a bit complicated, I don't want to give it to you in the first iteration. So we'll do a simpler version, which is called the Idealized PageRank algorithm, and it only works for certain kinds of web graphs. Now, before I get started, let me kind of just briefly review what we did last time. So we talked about what was a graph and what was a directed graph. And this slide here mentions what the input for the computer program would be. The algorithm is going to take this graph as its input, and then it's going to produce as its output a probability distribution, basically a vector whose components are non-negative and which sum to 1. And because generally these components are not going to all be equal, some numbers here would be larger than the others, we end up getting a ranking of the web pages, right? So if this was the output, that means that web page A, which has a rank of, which has a score of 3/9, is considered to be more important than web pages B, C, and D, each of which have a score of 2/9. So in the end, this output is a probability vector, which basically gives you one way to rank the pages, okay? And since the input is only a graph and not the query terms, this particular probability vector by itself would not be sufficient to give a complete ranking of the web pages. So what Google does is it uses the PageRank vector, which is this vector, along with hundreds of other properties to come up with a final ordering. So another property besides, the link structure of the web graph is the actual query terms that you are searching for and how well they are matched in the corresponding web page. So it's quite possible that web page B has the query terms in it, and therefore based on a content-based ranking, meaning it's the actual text and the actual content of web page B, maybe in the end, Google will decide that even though the PageRank score of A is larger than the PageRank score of B, the content-based ranking of web page B is higher than the content-based ranking of web page A, and therefore in the final ranking that I output to the user, web page B will come first, okay? Exactly how these many properties are combined is a trade secret. It's Google's secret. People outside the company don't know their current method. And probably, people believe it uses machine learning and to determine the weightage for the many properties that are used and that are combined. Okay, so our goal today is to look at the algorithm which takes this web graph as its input and then which will output some kind of a probability vector. Okay, that's the goal for today.